Let us find out potential due to an electric dipole. First of all, just quickly revise what is electric dipole. So it is a system of two charges, q and minus q, and it is separated by a distance 2a. All right. So if you have minus q charge and plus q charge, and if this charges are separated by a distance 2a, then we say it is an electric dipole. And there is something called dipole moment, that is P. It is a vector quantity. It is equal to 2aq, and since it is a vector quantity, we use a vector element, that is our p cap, unit vector p. And the direction of electric dipole moment is from negative to positive charge. So this is the direction of p. We have to find potential due to this setup, this dipole. Okay, so let us go to the figure. You can see the figure here. So certain things we have to establish before we even start. One is that, so there are two charges, and this dipole has a center O, and this center is r dash distance away from the point where we have to find the potential. Sorry, this is r distance away. Okay, so the position vector of the dipole, or position vector of the dipole is O at the origin. Okay, and the position vector of the point P is r. Other things are given as the angle between the dipole moment and the position vector r, okay, is theta. And if we separately see what happens with the charge q and minus q, okay, so q charge is r1 distance away from the point P, and minus q charge is r2 distance away from the point P. Now we simply apply the potential due to a point charge like q, okay, at point P. What would be the potential at point P due to the charge q? Then the formula of potential is simply V is equal to 1 upon 4 pi epsilon naught charge q divided by the distance, that is r1, and that of the potential at P due to minus q charge would be V, suppose this is V q and this V minus q is 1 upon 4 pi epsilon naught minus q divided by r2 distance, this distance. Then total potential V due to this dipole is the sum of these two potentials. Okay, so one is q by r1, here you can see, and the other one is minus q by r2, and 1 upon 4 pi epsilon naught is common for these two. So this is the formula for the potential due to a dipole. But what is intriguing here is that we don't know the value of r1 and r2. So till here it is very easy, okay, to understand what is the potential at a point P due to a dipole. But then we have to figure out how to get rid of r1 and r2. Instead of that, we will use r for the final formula. Okay. There are other ways of arriving at the solution, but we will stick to the NCERT, and it is really interesting to see what they have used. So first they have used cosine rule here. This is called the cosine rule, in which if we consider this a triangle, okay, where the angle between two sides A and R is theta, then what is the value of the third side. So we can find out using the cosine rule. Now here you have to keep in mind that this angle is less than 90 degrees. So if it is less than 90 degrees, then we can use the cosine rule as the square of the third side. The square of the third side is equal to the square of the first side plus square of the second side. So square of the first side is r square plus a square. And because theta is less than 90, we will use minus 2ar cos theta. And through this, we can find out the length of the third side. Okay, so because we now know the third side, the square of third side is r square plus a square minus 2ar cos theta. And if the angle between two sides r and a is more than 90, then and less than 180, then we will be using this formula where r2 square is equal to r square plus a square, and instead of minus 2ar, here it is plus 2ar cos theta. Okay. Also keep in mind that the distance a, this distance a is too small than the distance r. Okay, so we will work on that also. So let us go to the next step. Since r is way bigger than a, then what we will be doing here, that we are actually taking out a r square from the first from the right hand side of the first equation. So from the first equation, we are taking r square common on the right hand side. So r1 square on the left hand side is the same, but on the right hand side we are taking common r square. So once we take common r square here in this equation, what happens? The first term r square we are taking from the right hand side, so the first term will be 1, and then it will be, the second term will be plus a square by r square, and the third term will become 2ar cos theta will become 2a, because r we have taken, r square we have taken out, so 1 r will be in the denominator, and this will be something like this. Okay, so the exactly same thing what you can see here. Okay, now the next step is, since r is way bigger than a, then r square will be too big and a square will be too small. Okay, so in this case we will just eliminate this element or this term, so we are not using this term. So with only these two terms, it is sufficient to understand the relation of potential at a point. Okay, so you see that in the next step, the third term is eliminated. And for r2 square, it is the same, the third term is eliminated. So now we have r1 square is equal to r square and in the bracket 1 minus 2a cos theta by r, and for r2 square it is r square and in the bracket 1 plus 2a cos theta by r. And the next step is we take the under root both the sides, so r1 square is equal to r square 1 minus 2a cos theta by r will become, if we do the under root both sides, so it will become r1 is equal to under root of r square is r, and this term 1 minus 2a cos theta by r will be in the power 1 by 2. So under root 1 minus 2a cos theta by r. Okay, but in our formula for the potential, we are dealing with something 1 by r1 and 1 by r2, q by r1 and q by r2, you can see here. So we have to make sure that the expression is in that form only. So if we flip this thing r1 to make it 1 by r1, then we have to flip everything on the right side also. So it will become 1 by r and 1 minus 2a cos theta by r, and the power is 1 by 2. So this power will become minus 1 by 2. And that you can see here what NCERT has done. So this till this point we are clear. And this is still too clumsy. So we have to make it in a better form. So what we will be doing is this term 1 minus 2a cos theta by r and to the power minus 1 by 2, we have to simplify it. And how can we do it? We can use the binomial theorem. Okay, so one of the expression that if 1 minus x to the power n is there, then we write it 1 minus nx. And there are many more terms that will come, but we will ignore all these terms. Why? Because the further terms will use these quantity a and r in their squares or bigger powers. So we have already established that square of r and square of a will actually diminish the value. It will become too small and it can be ignored. So we will only focus on the first two terms. Okay. So the same is happening here. So if we do 1 minus, instead of x we write 2a cos theta by r, and the power is minus 1 by 2 instead of n, then the formula says it is 1 minus n. Our n is minus 1 by 2, so it will be minus 1 by 2, and then x, our x is this value 2a cos theta by r, so it will be 2a cos theta by r. And what do we see here? The minus sign here you can see will become plus, so 1 plus, and then also 2 can be cancelled, so it is 1 plus a by r cos theta, and this is what you can see on the right hand side. The term 1 minus 2a cos theta by r to the power minus 1 by 2 is now 1 plus a by r cos theta, and the same for the r2 part. So here because our x is positive, so instead of negative, the positive formula will be used, and positive formula is the same, 1 plus x to the power n is equal to 1 plus nx, and we get this value after solving it. So our 1 by r1 is now 1 by r 1 plus a by r cos theta, and 1 by r2 is equal to 1 by r 1 minus a by r cos theta. And these, if we use in the formula, v is equal to q by 4 pi epsilon naught 1 by r1 minus 1 by r2, will become v is equal to, instead of we will write q upon 4 pi epsilon naught, but instead of 1 by r we will be using this expression. So this expression is 1 by r 1 plus a r cos theta, and then minus 1 by r and 1 minus a upon r cos theta. So we need to expand it. V is equal to q upon 4 pi epsilon naught. So this is multiplied to 1, then 1 by r plus a by r square cos theta, and then this is 1 by r, and it is multiplied by 1, and then this minus and this minus will become plus. So plus a by r square cos theta, and then we can simply cancel out 1 by r because one is positive, one is negative, and v is equal to q upon 4 pi epsilon naught multiplied by a by r square cos theta plus a by r square cos theta is 2a upon r square cos theta. Further, this is v is equal to 2aq by 4 pi epsilon naught r square and cos theta. And 2aq is actually our p. So this is dipole moment. So our v is p divided by 4 pi epsilon naught r square and then cos theta. And if you remember the diagram, once again the figure, so the q minus q and plus q is here, and this is the dipole moment p, okay, and the point is here where we have to find the potential, and this is r. So angle between r and our dipole moment is theta. So in this case we can say that p dot r is p r cos theta, okay, and if we divide it by the magnitude of r, then it is actually p r cos theta by magnitude of r. Okay, so this r will be cancelled. So actually p dot the unit vector r is p cos theta. It simply means that projection of p dipole moment on the radial vector r. So this projection of p on r will be p cos theta. So this element is p cos theta. Okay. From there we can write that our v is actually p cos theta is actually p dot vector r divided by 4 pi epsilon naught r square, and this is the potential due to an electric dipole at a point P. And also keep in mind that R is actually just the magnitude of R is actually way bigger than A. So this is also an important point. So if the dipole is there and then if the point is too close, then we have to figure out something else. Okay, then we have to consider all other elements, even the square of A and R will be considered. But for a system, for a dipole whose the A distance is way smaller than the position vector of the point P, then this is the derivation and final expression for potential. Okay, now I also urge you to go to your NCERT book and read the important points there, like what is the conclusion of all this derivation. Certain things are there which is there in the book if I would have missed it. And also you can go to www.proteacher.in and you can go to 12th physics section. There you will find notes and more study materials. Thank you.